Hello people! As you can see, the CNC machine is now dark and the manual mill is lighted up. And also, as you can see, I've got a little bit of project going on for it. But before we go into that, let me make you a little announcement, which is that I'm now a full-time machinist, which is awesome. It's like a dream of 10 years at least come true. So my February is already 100% booked, and new work is coming in slowly but steadily. I will be doing some more advertising soon, but I am pretty confident that I am getting enough work. I know it's not gonna be easy in the beginning, but I have prepared my mind for not having a lot of money to use. Not that I have had much money before. And actually I am still listed at my old work. I kind of work part-time there, which is awesome also. So if I ever don't get enough work here, I should still be able to do some hours at my previous work, which is an awesome deal actually. And so far I'm loving it. It's just awesome. It's so great. Firstly, being at home all day, my distance to work is like 30 steps compared to the 90 kilometers per one way before, which is like 60 miles or 50 miles one way. So each day I'm now saving 2 hours from not driving to work. And also when I'm at home I can heat the building by wood, so not having to use nearly as much oil as before. So that's saving. And of course the work, I just love it. So far I just love it, at least. I hope it's gonna take me many years, if ever, to stop loving it. Okay. So, let me tell you a little bit what's going on. So, about this project first, I've got these square aluminum stock pieces, which are like 1.5 meter tall. I think it's like 5 feet maybe, and 30 by 30, so about 1 3/8 from side to side. And this is what I'm doing to them. So actually these are gonna be crowbars, and after I have kind of sharpened the ends, I will turn down the shank, which is a pretty interesting operation on the lathe. The length to be turned is, I think it's 110 centimeters, so over a meter, which is like 3.5 feet or something like that. So obviously that's gonna be in a lot of unfavorable machining conditions, very unfavorable conditions actually. So what I'm doing first, I'm doing it in 2 steps. So first I'm chucking these with about 5 centimeters or 2 inch sticking out, and I'm gonna center drill it and face it. And I'm gonna do it all of these at once. And then for the second setup, I'm gonna set it between the chuck and the center, live center, and I'm using a following rest. meaning that I'm actually taking it down in one single pass, which is pretty rough, but I have done a few of these and it does work. Just need the right inserts and speeds and feeds. So using a slower feed to rough it out, and then because the shank needs to be rough, because it's a crowbar, you have to get a good grip of it. So the second pass will be with a much faster feed, so that it leaves a rough surface. So that's pretty interesting also, but I think this is almost as interesting as that. So later I'll show you more about the turning work, but now let me say you a few words about the milling work. And I'm doing this on the manual mill because these do not fit inside the cabin of the CNC mill, and actually I think it's such a simple operation that it's maybe even easier to do on the manual mill. But a DRO is a must to have here. So I have made up a jig like this. It's a pretty simple jig. It's a piece of 40 by 60 steel square or rectangular, and I have milled slots for the aluminum pieces to go in, and I have 5 bolts holding it to the table by T-slots, and these 8 nuts, 8 bolts hold the pieces, and between the bolts and the aluminum I have a stock of 8mm steel, so I don't make any scratches to these. And it's a pretty tight fit between here. It's like 10 to 20 hundredths of a millimeter, or 4 to 8 thousandths of an inch, so that I can get them straight, and they're always in the same spot. And I have also made some stops right here. It's kind of a makeshift kind of thing, because I didn't have a piece long enough to make it from one piece. So I utilized a shorter piece, which I cut in 2 longitudinally, like this, and I used that to make 2 pieces, and they're held on by tiny M6. Can you see anything? Tiny M6 screws. Come on. No focus, okay. And to make the M6 bolts fit to these pretty large T-slots, I made adapters with outside thread of M12 and inside thread of M6. So that's what's holding them in. They're not super tight. I think eventually I will make another stop which is a little bit more rigid. So when you slide these bars in, you have to be a little bit careful not to tap these stops. But what I did, I used a Sharpie to mark the edges of the stops. So every now and then I will check if the stops have moved, and then I will reset. So far I haven't run into that. So it's actually a very rigid setup. I'm happy with that. And how I'm cutting it is I have this face mill, a 100mm or a 4-inch face mill, which is especially designed for aluminum, and it has extremely sharp inserts, aluminum inserts. They are pretty much as sharp as the sharpest knife you have ever seen, and they have a very positive rake. So they leave a pretty good finish. It's like a mirror. And this surface finish comes from a 5mm depth of cut, which is huge. So I think the total to be removed is 12 millimeters. So actually the first cut is 7 millimeters and the second cut is 5 millimeters. So those are pretty huge cuts. So even if I took a finishing pass, it would be no less mirror than an actual mirror. And yes, this is putting quite a bit of strain on the milling machine, but it's working very well. So, and the speeds I'm using, spindle speed is 1120 RPM, 1120 RPM. And the feeding speed is 500 millimeters per minute, which gives a chip load of 0.09 millimeters per tooth, which is like, it's like 4 thousandths per tooth, which is a little bit on the low side, but it seems to be working fine. And it's actually, as it is, it's so fast that I don't think I even want to try any faster. This is way fast enough. It's taking like, well, 500 millimeters per minute, and this is about 500 millimeters, so it's taking maybe a minute to pass it over. And then flip these pieces around and do the other side. So I think I can show this to you. So I will not just be talking. And I have already zeroed the z-axis, so I'm all set to go. And I have I have the y-axis locked, of course. And also the quill has to be locked very tight. And this is not the most accurate of operations, but they still come out pretty uniform, extremely uniform actually. How I dialed in the angle is I had an indicator on the spindle and I was turning the spindle with the indicator against a sample that was given to me. And that's what I'm going to use for calibration in future. And I'm always milling from this side to that side, so going from thick to thin as you're supposed to go, and that really helps. It gives a much nicer surface finish, and it cuts nicer also. Okay, let's see. Okay, have to be in time to stop it, so I don't hit my pillar here. Okay. Look at this. If that's not a mirror, I don't know what is. Beautiful. And by the way, this is 7075 aluminum, so it's not easiest tough to machine. It's pretty much the toughest aluminum there is. And look at the amount of chips. Beautiful chips. I made a little bit of a mistake. I had forgotten to the feed to 1000 millimeters per minute, so it was feeding twice as fast as it was supposed to. So it was trying to stall the motor, but I flipped the switch and halved the feed again. Okay, so that's pretty much how it goes. It's pretty rough, but that's how it goes. Okay, so I hope you liked seeing a little bit of manual machine action again. I also have some video material about CNC machining, again, if you like to. But actually I would like to ask you, what would you like to see? because I'm now only running one job at a time, I should have, and actually I do have more free time, so I should also have more time to edit videos. So, if you have any suggestions for what you would like to see, please let me know. Okay, thanks for watching and see you again. And wish me good luck, I really need that now. Bye.